In this video, we're going to take the little bit that we know about quadratics and try to apply them to some real-life situations. In example 5, the path of a ball after you've kicked it can be modeled by the equation y equals negative 0.1 x squared plus 4x, where x is the horizontal distance in feet and y is the height in feet of the ball. What was the height of the ball at its highest point, and how many feet had the ball traveled horizontally at this height? So what I like to do pretty much anytime I have a word problem is, if possible, I'm going to try to draw the situation or make a sketch if I can. So imagine, now you're going to not like my drawings here, but let's say we got a guy here, or that's you, and you've kicked a ball, right? It was at your foot, and you've launched it, you got underneath it a little bit, and you kick the ball, and it goes up. Of course, it reaches some highest point, and then it's going to come downwards like so. Not the greatest drawing in the world, but it does resemble a parabola, or maybe not the greatest parabola. Let's get back to maybe a better drawing here. I feel ashamed. Let's try it again. A little bit better there. So the path of the ball more or less might look something like this. So our job is, we want to find what is the height of the ball at its highest point. Well, this point right here is the highest point, and so we want to know what is that height, how far is it off the ground. Let's call that h for height. And we also want to know how many feet had the ball traveled horizontally at this height. So we want to know how far is this value as well. Let's just call that x for right now. So we want to know what that is. By the way, you might notice that coordinate right there is the all-important vertex. Basically, if we know what the vertex is of this parabola, we can answer these questions pretty easily. Now, by the way, this parabola does match more or less this equation, because if you think about it, the a value here is negative 0.1, and that tells you that the graph of the quadratic function opens downwards. Remember, a negative a value means it's going to go downwards, and thus it has a maximum value, and it's going to occur at the vertex. Now, this function is written in standard form. Remember, standard form is the ax squared plus bx plus c, and let's think about what the a value is. We already know it. It's negative 0.1. My b value, if you look at it, is the coefficient of x. That is that 4 right there. So that is my b value. Now the c value is what's tacked on the end. If you think about it, there is nothing beyond that 4x. You can think of it really as being like a plus 0. So my c value is 0. Now, if we're graphing from standard form, the x-coordinate is negative b over twice a. So I'm going to do the opposite of b, which is negative 4, over twice the a value, negative 0.1. That's going to be negative 4 over negative 0.2. And I think if you divide those, you're going to get 20. You might want to double check me, but I'm pretty sure 0.2 is 1/5, and if you divide 4 by 1/5, you're really multiplying 4 times 5, and you're going to get 20. So I know my x value is 20, so this value is really 20 feet, and the corresponding y value, to get that height, I'm going to have to substitute that in. So I'm going to do negative 0.1 in parentheses 20 squared, and then it was plus 4x, so plus 4 times the 20 should give us that amount. Now I would use my calculator at this point to take care of the rest of this, and so, you know, on second thought, we don't necessarily need to use our calculator. I know you might, but these numbers aren't too terrible. If we do negative 0.1 times 20 squared, 20 times 20 is going to be 400, and then we have plus 4 times 20, that's just 80. Negative 0.1 is negative 1/10, so basically I have to divide 400 by 10, which leaves 40. I know I have negative 40 plus 80, that's just going to be 40. So we have a height of 40 feet. That's a pretty good kick. So the maximum height of the ball reached 40 feet, so that is 40, and at this height the ball had traveled 20 feet horizontally. A great question might be to kind of add this, just for giggles. I'd like to know how far total did the ball travel before it once again hit the ground. So how far did the ball travel horizontally before hitting the ground again? Well, it went 20 feet halfway. Now remember, parabolas are symmetrical, so that means this must also be another 20. So all you'd have to do is 20 feet plus 20 feet to get a total of 40 feet horizontally. That would be another little addition I could add on this one. Let's do one last problem. In example 5, assume that the path can be modeled by this new equation. What is the height of the ball at its highest point? So again, we kick the ball, and so we kicked the ball and it traveled the path of a parabola. We want to find what is the height, so that value. Really, ultimately, that's the y-coordinate. If that's the vertex at x comma y, we want to know what is the height, the y-coordinate. So this is in standard form, my a value being negative 0.2, my b value being 4, and my c value is 1 in this case. If you remember, the x-coordinate of the vertex is negative b over twice a. So negative b is going to be negative 4 over twice the a value, negative 0.2. That's going to be negative 4 over 2 times negative 0.2 is negative 0.4. And if you divide negative 4 by negative 0.4, you're going to get just 10. So this is my x-coordinate of the vertex, keep in mind. We just figured out, let's get rid of that. The x-coordinate of the vertex is 10. We really don't want that. The problem is asking for the height of the ball, not necessarily how far horizontally it traveled. So now I need to substitute that back in to find out my y-coordinate here. So I'm going to do y equals negative 0.2 times 10 squared plus 4 times 10 plus 1. So this is going to be negative 0.2, 10 squared is 100, so I have to multiply that to 100, plus 4 times 10 is 40, plus 4. 0.2 times 100 is just going to be 20, plus 40 plus 1 is really just 41, and I get 61 feet. So I think the height of this ball is going to be 61 feet in the air. And pretty good kick. I guess for me it would be. I don't know for some of you guys. Anyway, 61 feet would be your solution here.